I want you to picture a modern air show, or honestly, just think of any, blockbuster military movie from the last couple of decades.
Yeah, we all know the ones.
Right. And what do you see? You see the fighter jets. I mean, they're fast, they're lethal, they're just decisive.
Pulling those high-G, gravity-defying maneuvers.
Exactly. You've got the afterburners glowing, the deafening roar of the engines, and, it's impossible not to be in awe of that kind of power. We are completely conditioned to look at those jets and think, well, right there, that's the ultimate symbol of modern warfare.
It's the visible edge of the spear, really. I mean, it captures the headlines, the budgets, and definitely the public imagination.
Oh, for sure. But what if I told you that we're going to look right past those flashy jets today?
Yeah, we're totally ignoring them.
We are. We're ignoring the fifth-generation stealth fighters and the laser-guided missiles to find the actual decider of modern geopolitical power. So we've been digging through a stack of research, particularly an incredibly eye-opening piece called The Silent Backbone, the strategic geometry of aerial refueling.
It's a great source. Really detailed.
It is, and our mission for this deep dive is to uncover how a seemingly boring, highly technical, logistical task, like literally pumping fuel from one airplane to another mid-flight, is actually the ultimate trump card for the world's superpowers.
Okay, let's unpack this, because reading through this completely flipped the script for me on what actually makes a military powerful.
It's a massive paradigm shift for sure. The core thesis here is deceptively simple, yet it redefines the entire concept of combat. Basically, fighter jets might win the dogfights, but aerial refuelers determine how those battles are fought in the first place.
Yeah. Everyone obsesses over the what, right? The firepower, the Mach speed, the stealth coating, but the refuelers dictate the why and the where. Yep. They set the physical boundaries of where power can be projected and, how long an operation can actually last.
Which means they're giving commanders the actual flexibility to respond to a changing map, rather than just guarding a fixed line somewhere.
Yeah, that's the crux of it. Without aerial refueling, even the most technologically terrifying air force on the planet is operating inside an invisible cage. And that cage isn't built by the enemy's air defenses.
It's built by their own fuel gauge.
Exactly. It's built by the jet's own fuel gauge. Aerial refuelers take air power and transform it from a localized tactical tool into a continuous global strategic instrument.
So we aren't just talking about flying gas stations today. We're talking about the invisible geometry of power.
Man, I love that phrase, the invisible geometry of power, because to really grasp it, you have to move away from the Hollywood visual of a dogfight and think about the brutal mathematics of flying.
Oh, the math is unforgiving. It really is. Let's talk about the physical mechanics for a second, because the sheer absurdity of mid-air refueling is lost on most people, I think. You've got a $100 million fighter jet loaded with explosives, flying at, 500 miles per hour?
Give or take, yeah.
And it's trying to perfectly match speeds with a massive cargo plane just a few dozen feet away.
It's an absolute engineering marvel, and the physical difficulty is just staggering. You essentially have two methods they talk about. There's the probe and drogue system.
Right, the one with the basket.
Yeah, exactly. The tanker trails a heavy pressurized hose with a basket on the end, and the fighter pilot has to manually fly a probe attached to their jet into that basket. I mean, you're dealing with wake turbulence, high winds, and you need absolute precision.
And then there's the flying boom method, which honestly sounds even crazier to me.
It is pretty wild.
You've literally got an operator laying on their stomach in the back of the tanker, using a joystick to fly a rigid metal pipe into a receptacle on the roof of the fighter jet below them.
Yes. The boom operator is manually flying that pipe to make contact. And if the speeds don't match or someone hits a pocket of turbulence, the physical forces can rip the refueling receptacle right off the fighter jet.
Oh, wow. Just tear it right off.
Literally tear it out of the airframe. But despite that extreme difficulty, mastering this maneuver fundamentally alters a military's capabilities. What's fascinating here is the military terminology used for this. The text calls it a force multiplier.
Right.
That's a buzzword thrown around in corporate boardrooms all the time. But in aerial warfare, it carries a very literal mathematical meaning.
I want to stop you right there, actually, because I always hear force multiplier and just assume it means, makes things better.
Most people do.
But we're talking about exponential amplification here, aren't we? It's not just, we have more gas, we can fly further.
Far from it. Think about the physics of takeoff weight. Every aircraft has a maximum weight. It can lift off the runway safely.
Right. There's a hard limit.
Exactly. So if a fighter jet has to carry a full load of fuel To reach a distant target, it has to sacrifice the number of bombs or missiles it can carry. The fuel weighs too much.
Oh, I see. So it's a trade-off.
A massive trade-off.
Yeah.
But if you have a refueler waiting in the sky, that fighter can take off with a minimal amount of fuel and an absolutely massive payload of ordnance.
Wait, really? They just take off almost empty?
Mostly empty of fuel, yeah.
Yeah.
It gets airborne, immediately meets the tanker, fills up its tanks, and heads to the target heavily armed.
So a single refueler doesn't just extend the range. It could literally double the destructive output of an entire fighter squadron.
Yes, and it completely removes the dependency on forward air bases. If you don't have refuelers, you have to build runways right near the front lines.
And those runways are obvious, highly vulnerable target.
Exactly. Refuelers allow you to base your jets hundreds or thousands of miles away in absolute safety while still projecting continuous force over the battlefield.
The research breaks down this contrast beautifully, I think. Without refuelers, operations are described as linear and predictable. It's like having a fiercely protective guard dog, but the dog is tied to a chain in the yard.
That's a great analogy.
Right. It doesn't matter how aggressive the dog is, its threat radius is entirely limited by the length of that chain. If your enemy knows the fuel capacity of your jets, they can just draw a circle on a map around your airbase and know exactly where they are safe from attack.
And predictability in warfare is fatal. If an adversary knows your jets only have, say, an hour of loiter time before they have to turn back, they just wait you out. They hide, wait for you to leave, and then move.
Because you have to go home to get gas.
Exactly. But introduce a fleet of tankers, and that geometry we talked about changes from a fixed circle on a map to something entirely fluid and elastic.
The tether gets cut.
The tether disappears completely.
Okay.
Now, your fighters can loiter over a contested area for hours, waiting for the perfect moment to strike.
Which changes everything.
Totally. They can take highly indirect, circuitous routes to bypass radar, appearing exactly where the enemy least expects them. Your deep strike missions can penetrate thousands of miles into hostile territory without needing to land and refuel.
This creates what the strategists in the source call strategic uncertainty. The adversary can't trust their math anymore. They can't calculate your limits because the refueler hides them.
Precisely.
But, this brings up a glaring question for me. If the mathematics and the geometry clearly point to logistics being the ultimate trump card, why do we still obsess over buying more fighters? Like, why isn't every defense minister on Earth screaming for more tankers?
Well, because prioritizing logistics over firepower requires a tremendous amount of strategic discipline.
What do you mean?
When a nation is facing an immediate, localized threat, politicians and generals want the visible deterrent. They want the flashy jet that can shoot down the enemy tomorrow. Building a massive fleet of logistical support aircraft is expensive, slow, and frankly, unglamorous.
Yeah, it doesn't look great on a recruitment poster, does it?
It really doesn't. And to see the real-world consequences of this dynamic, we just have to look at one of the most complex geopolitical borders on the planet today, the dynamic between India and China. The research provides a fascinating case study on this exact strategic dilemma.
Here's where it gets really interesting, because mapping this abstract geometry onto the Himalayas is where the stakes get incredibly high. And just to be clear for you listening, we're just looking at what the source material lays out here, analyzing the strategic choices both sides are making based on the data.
Right, strictly looking at the logistical capabilities outlined in the text.
Exactly. So looking at India's side of the equation, they possess immense tactical strength. They operate a highly capable, technologically sophisticated fleet of fighters. We're talking about platforms like the Su-30 MKI, Rafales, and Mirage 2000s.
In a sheer dogfight, it's a terrifying lineup.
Yeah.
Very capable.
Yeah, absolutely. But then you look at their logistical backbone.
Right, and that's where the bottleneck becomes obvious. India's aerial refueling capability currently hinges on a very limited number of IL-78 tankers.
Which are what, Soviet era?
Yeah, the IL-78 is an older Soviet-era platform. While it provides essential capability, the sheer scale of India's operational requirements dwarfs what those few aircraft can provide. Furthermore, they are dealing with severe serviceability challenges.
Let's translate serviceability challenges for a second. That basically means the planes are highly prone to breaking down and spend entirely too much time in the hangar waiting for parts, right? Leaving even fewer available for actual missions.
Correct. Maintaining older, complex, heavy aircraft is a logistical nightmare in itself. And despite recognizing this gap, multiple attempts by India over the years to procure additional refuelers have faced massive bureaucratic delays.
Cancellations, procedural hurdles, it's been tough.
Exactly. So while their fighter fleet expanded and modernized rapidly, the vital refueling capability simply didn't keep pace.
It's wild. I mean, you have billions of dollars tied up in cutting-edge fighters, but without sufficient gas stations in the sky, their operational reach is heavily constrained.
Yeah, the reach is severely limited.
If India needs to execute deep strike missions into high-threat environments, or if they're forced into a multi-front scenario, like having to defend against Pakistan on one side and China on the other simultaneously, that lack of refueling capacity severely restricts their flexibility.
Right, they literally might not have the fuel to pivot assets across the subcontinent fast enough to respond to threats.
Now, contrast that with China's approach over the last decade. The regional dynamics shift drastically when you look at how the People's Liberation Army Air Force, the PLAAF, is evolving.
Yes, China has explicitly recognized the strategic necessity of aerial refueling and has poured massive investments into expanding and modernizing its tanker fleet.
And the standout example in the research is the YY-20.
The YY-20 is a watershed platform for them. It's not a repurposed aging Soviet plane. It is a modern, domestically produced, purpose-built strategic airlifter and refueler.
Oh, wow. Purpose-built makes a huge difference.
It does. It has a significantly larger fuel payload, more efficient engines, and modern avionics. But more important than the specs of the plane is what its induction signifies structurally.
Right.
China is actively building a logistical backbone to transform the PLAAF from a regional defensive force into a true expeditionary tool.
Expeditionary tool, meaning they are designing a military meant to project sustained power far beyond their immediate borders out into the Pacific or deep into the Indian Ocean.
Exactly. They understand that possessing advanced stealth fighters like the J-20 is completely irrelevant if those fighters can't reach the conflict zone and stay there.
Makes sense.
By mass-producing the YY-20, they are ensuring they can support long-range bomber missions, extend the reach of fighter escorts, and maintain a continuous intimidating presence over highly contested regions, like the South China Sea or the Taiwan Strait.
The contrast here is stark, really. It's not just a quantitative difference of who has more planes. It's a fundamental conceptual difference in how they view the role of air power.
Very much so.
The text highlights that India has built a formidable shield and a sharp sword for regional defense. But China is laser-focused on the infrastructure required to carry that sword across the globe.
And in an era of intense geopolitical competition, influence is directly tied to reach. The ability to deploy rapidly and operate beyond your immediate geographic constraints is what separates regional powers from global superpowers.
Right.
Aerial refuelers are the physical instruments of that strategic reach.
I follow the logic entirely, but there is a massive glaring issue here that I can't shake.
What's that?
Well, we've just established that these tankers are the most important assets in the sky. They are the center of gravity for an entire air campaign. Doesn't that make them the biggest, juiciest targets imaginable?
Oh, absolutely.
Like if I'm an adversary commander looking at a radar screen, I'm ignoring the swarm of stealth fighters and firing every long-range missile I have at the massive, slow-moving gas station they rely on.
Yeah.
If I kill the tanker, the fighters fall out of the sky anyway, right?
You've hit on the exact vulnerability that is currently keeping defense planners awake at night. The paradigm is shifting rapidly. Traditional tankers are basically converted commercial airliners.
Big, slow tubes.
Exactly. They have huge radar cross-sections, they are slow, and they operate under the assumption that they will be safely tucked away behind friendly lines, far from enemy surface-to-air missiles.
But with modern missile technology, there are no safe backlines anymore, are there?
Exactly the problem. Adversaries have developed ultra-long-range air-to-air missiles specifically designed to hunt AWACS.
Those are those radar planes with the big domes on top, right?
Right, the early warning planes. And they're designed to hunt those, and aerial refueling tankers. The safe distance is shrinking dramatically.
Which is terrifying.
It is. And this brings us perfectly to where the technology is heading next, because survivability is now the defining metric.
So what does this all mean? How do you fix that? Do you just slap heavy armor and defensive turrets on a Boeing 767?
No, armor is way too heavy. It ruins the fuel efficiency, which defeats the purpose.
Ah, right.
If we connect this to the bigger picture, the future of this technology is moving in three radically different directions to solve the survivability problem.
Oh.
The first major trend the research points out is stealth. Defense contractors are actively developing stealth-enabled refueling platforms.
Wait, how do you make a massive flying fuel tank stealthy? That seems impossible.
You move away from the traditional tube and wing design of a commercial airliner and look toward blended wing body designs. Imagine something closer to the B-2 stealth bomber, like a flying wing shape.
Oh, okay. That looks super futuristic.
It does. You incorporate radar-absorbent materials and hide the engines to mask the thermal signature. The goal is to build a tanker that can slip much closer to the front line or even inside contested airspace without lighting up the enemy's radar.
Which allows fighters to penetrate even deeper before topping off their tanks.
Exactly.
That makes sense, but you're still putting human crews in incredible danger if they get caught.
Which leads to the second major trend: drones. Unmanned refueling systems. The U.S. Navy is already pioneering this with platforms like the MQ-25 Stingray.
Okay, what is that?
It's an unmanned drone specifically designed to launch from an aircraft carrier and refuel fighter jets midair.
Hang on. We talked earlier about the insane physics of midair refueling the wake turbulence, the precision. We are trusting an autonomous drone to handle the most delicate, dangerous maneuver in aviation.
I know, it sounds like science fiction, but the software and sensor suites have advanced to that point. The drone uses machine vision, precise GPS, and complex algorithms to stabilize the drogue basket or the boom.
That's unbelievable.
By removing the human crew, you completely change the risk calculus. You can send drone refuelers into incredibly dangerous, high-threat environments where you'd never risk a crewed tanker.
Yeah.
Furthermore, it allows for distributed operations.
Breaking the eggs out of one basket, essentially.
Yes. Instead of relying on one massive, highly vulnerable tanker, you launch a swarm of smaller, stealthy drone refuelers scattered across the battle space.
Oh, I see.
If an enemy manages to shoot one down, the network seamlessly reroutes the fighter jets to the other drones. The mission just continues.
You just used the magic word network card. Because the third trend the research highlights is that these planes are going to do a lot more than just pump gas in the future.
Yes, the evolution into what we call network-centric warfare. The concept of a tanker functioning purely as a flying gas station is essentially dead.
Really?
Yeah. Future refuelers will serve as vital nodes within a massive, interconnected digital web. Because they are already positioned high in the atmosphere and have enormous power generation capabilities from their massive engines, they are perfect platforms for carrying advanced sensors, communications relays, and situational awareness data links.
So let me get this straight. While a stealth fighter is plugged into the boom getting fuel, the tanker is simultaneously downloading the fighter's sensor data, processing it, and beaming it via secure lasers or satellite back to a naval fleet or command center thousands of miles away.
Exactly. It acts as the router for the entire battle space. It coordinates the data flow between drones, ships, satellites, and fighters, integrating the entire war effort into a single, cohesive picture.
That is just, it's mind-blowing. The ultimate takeaway from digging through all this is that the nature of military power is just deeply misunderstood by most of us.
It really is.
The research argues forcefully that militaries need to stop fixating on individual platforms. Buying a marginally faster fighter jet doesn't win a war. Victory comes from the integrated system. You have to recognize the supreme importance of the support architecture.
That is the essential lesson here. And the author distills this into a brilliant, almost philosophical observation, they write. In contemporary conflict, visibility obscures reality.
Visibility obscures reality. I love that. We get so distracted by the explosions, we miss the logistics.
Precisely. The most intimidating, highly visible elements of a military carrier. You know, the aircraft carriers, the supersonic bombers, the hypersonic missiles, they monopolize our attention.
Because they're loud and scary.
Right. But they are rarely the most decisive elements. The actual outcomes of prolonged conflicts are determined by the underlying invisible systems. The logistics, the supply chains, the refueling networks.
Yeah.
Aerial refuelers operate away from the spotlight. They don't drop ordnance. They don't score air-to-air kills. But if you remove them, the platforms that do drop the bombs are instantly neutralized.
They are the ultimate enablers, and there's a conceptual distinction in the research that really drives this home, separating capability from continuity.
Right, yes. Capability is a measure of what can be done. It's the tactical strength. A fighter jet's capability is its speed, its radar, its weapons payload.
The continuity.
Continuity is a measure of what can be sustained. In modern warfare, conflicts are incredibly rarely decided by a single spectacular battle. They are wars of attrition. They are won by the ability to maintain combat effectiveness over weeks, months, or even years.
And sustainability is the ultimate deciding factor there.
Exactly. That's why the text rightly crowns these tankers the silent backbone. Victory belongs to the side that understands power is continuity.
It completely reframes how you look at the globe. You don't look at how many jets a country has. You look at how far they can push them.
Exactly.
And it leaves me with a final, slightly terrifying thought for you to mull over. We've talked about how refuelers currently operate in the background, out of the spotlight. But think about those future trends we just discussed. If militaries are transforming these massive tankers into stealthy, autonomous, heavily networked command nodes because they realize they are the absolute center of gravity, well, this raises a massive question about the future of warfare.
It does.
Will the aerial dogfights of tomorrow completely ignore the fighter jets? If the tanker is the single node that keeps an enemy's entire air force fueled, coordinated, and aware, the next major global conflict isn't going to look anything like Top Gun.
No, it won't.
It's not going to be aces swirling around in the clouds. It might just be a high-stakes, invisible game of cat and mouse, hunting the refuelers. Because if you can find and take out that silent backbone, the world's most advanced, lethal, billion-dollar fighters simply become highly aerodynamic bricks, and they just fall from the sky.
That's a sobering thought.
So the next time you see a blockbuster movie with jets doing loops over a battlefield, look closely at the edges of the frame and ask yourself, where's the gas station?
Thank you for joining us on this Strategic Vanguard podcast. If you found value in this analysis, don't forget to like, share, and subscribe to our channel. We bring you fresh podcasts every Monday here on YouTube and Rumble, and you can also catch the audio versions on Spotify and Amazon Music. Just search for Strategic Vanguard Podcast. For more insights, articles, and discussions, subscribe to our blog at strategicvanguard.com. Your support helps us grow and bring you more in-depth analysis on defense, geopolitics, and strategy. Until next time, stay informed, stay strategic.